You see, our universe is kind of like a finely tuned machine.
Scientists have found that there are about 20 numbers, 20 fundamental constants of nature that give the universe the characteristics we see today.
These are numbers like how much an electron weighs, the strength of gravity, the electromagnetic force, and the strong and weak forces. Now, as long as we set the dials on our universe machine to precisely the right values for each of these 20 numbers, the machine produces the universe we know and love.
But if we change the numbers by adjusting the settings on this machine even a little bit, the consequences are dramatic. For example, if I increase the strength of the electromagnetic force, atoms repel one another more strongly, so the nuclear furnaces that make stars shine break down. The stars, including our sun, fizzle out, and the universe as we know it disappears.
So, what exactly in nature sets the values of these 20 constants so precisely? Well, the answer could be the extra dimensions in string theory. That is, the tiny, curled-up six-dimensional shapes predicted by the theory cause one string to vibrate in precisely the right way to produce what we see as a photon, and another string to vibrate in a different way, producing an electron. So, according to string theory, these minuscule, extra-dimensional shapes really may determine all the constants of nature, keeping the cosmic symphony of strings in tune. By the mid-1980s, string theory looked unstoppable. But behind the scenes, the theory was in tangles. Over the years, string theorists had been so successful that they had constructed not one, but 5 different versions of the theory. Each was built on strings and extra dimensions, but in detail, the 5 theories were not in harmony. In some versions, strings were open-ended strands. In others, they were closed loops. At first glance, a couple of versions even required 26 dimensions. All 5 versions appeared equally valid, but which one was describing our universe?
This was kind of an embarrassment for string theorists because on the one hand, we wanted to say that this might be it, the final description of the universe, but then in the next breath we had to say, and it comes in 5 flavors, 5 variations. Now, there's one universe, you expect there to be one theory, not 5. So this is an example where more is definitely less.
One attitude that people who didn't like string theory could take was, well, you have 5 theories, so it's not unique.
This was a peculiar state of affairs because we were looking just to describe one theory of nature and not 5.
If there's 5 of them, well, maybe there's smart enough people would find 20 of them, or maybe there's an infinite number of them, and you're back to just searching around at random for theories of the world.
Maybe one of these 5 string theories is describing our universe. On the other hand, which one and why? What are the other ones good for?
But having 5 string theories, even though it's big progress, raises the obvious question, if one of those theories describes our universe, then who lives in the other 4 worlds?
String theory seemed to be losing steam once again. And frustrated by a lack of progress, many physicists abandoned the field. Will string theory prove to be a theory of everything? Or will it unravel into a theory of nothing?